Meine Damen und Herren, in Österreich, Ladies and Gentlemen here in Japan, ein herzliches Willkommen im Außenwirtschaftscenter Tokio, Ihrem Büro in Japan. Ladies and Gentlemen, welcome here at Advantage Austria, Tokyo, your office for Austrian companies here in Japan. I'm very excited today to have our annual review on the Japanese semiconductor AI robotics market. Arnold from the Austrian Embassy Commercial Section here working at the Außenwirtschaftscenter Tokyo as the deputy head. This is really the once in a year webinar where we really focus on the current progress that Japan is doing in the AI and semiconductor area. We had great movements. Many of you are working in the semiconductor industry, so you know Japan is a very interesting market these days. We have great developments, and overall these, I think we focus on three particular topics today: that's semiconductors, smart factory and robotics, and emerging technologies like AI and quantum. As a big picture, so to say, if you take one thing away from today, it's that Japan is really trying to build its own technological sovereignty. That means keeping data inside the country, building its own AI models as far as possibly, increasingly shaping and making sure that the procurement and supply chains are in Japan or at, and that's where Europe comes into play, like-minded players. Economic security is a huge topic on that whole semiconductor robotics AI field. We have added certain fields in the slides you will see later about geopolitical risk, economic security issues in the various chapters. For this particular webinar, we will not dive into this special topic because that alone would take an hour. So we very much concentrate on the technology field today. Then let me spend 1 minute on also introducing and promoting the upcoming information booth that we are doing at the JASIS 2026. That's Japan's leading fair for analytical and scientific instruments. We're doing an information booth, so there is no need for you to personally come here. We, that is Andy, my colleague, and then Luigi Finocchiaro, another colleague who has been working with the manufacturing industry for more than 20 years, will take care of our booth, will promote your information that you have for these fields, and we will send you the information later so you see what fields are covered in the booth that we have. And very particular, we have the organizer of the trade fair has offered us a free seminar slot. So inside the whole event space, we will have a seminar slot, usually well visited, and there we have 20 minutes to also introduce your solutions, your products. For anyone who wants personally to come here or will be here for a business trip, coincidentally, please contact us again. Of course, we are happy to help you with contacts here at the trade fair. So I think that we have quite a lot of people already online, so it's time to dive into the topic. And I would ask my colleague Andy to come online.
Yeah.
Thank you, Andy. Wonderful. Yes. So with you sharing the screen, I will turn my camera off and leave the floor to you and your trusted hands.
Okay, thank you. So let me share my screen. Yeah. Okay, good. Let me start. Thank you very much for all of you coming today. This is Andy Kondo. I'm a senior consultant in the field of the semiconductor, smart factory, robotics, and these days, yeah, I'm talking about a lot of AI things. I do my own business as the individual researcher and also innovation analyst, checking up what's going on, the cutting edge technologies, then translate that technology into the business language, then deliver the message to the big Japanese corporate. That is the my activity, what I do in Japan. So some of you, maybe you were here last year. Some of you quite new here this year. So I would check up, okay, what happened last year, 1 year? I talked about Rapidus, big semiconductor initiative activities happened in the northern part of Japan, 2 nanometer aggressive plan. Okay, that plan was presented last year. Then this year, pilot line running. I will dive into the detail later. Humanoids. Yeah, we talked about physical AI and the robot starts dancing and so on. This year will be more industrial discussion. We are going on. NIL, Nanoimprint technology. That is the new way of creating fine circuitry on the semiconductor, away from the conventional lithography method. This process is coming to the near to the mass production. We talk about it. Then generative AI. I know everyone using ChatGPT or Claude or Gemini, whatever. New type of discussion is happening each country, I believe, and also happening in Japan. That's what I dive in the first. AI and data sovereignty. So as Arnold mentioned, of course, geopolitical issues are really, everyone care about. I just made one box on the each chapter on the first page. Maybe you could read it. I will not dive into the detail, but maybe you can read it through later. Okay. So last year I talked about AI. Japanese people not really starting up using AI because okay, let AI write something that might be, oh, you are cheating. That way of thinking still existing, or some level of hesitation for the, let's say, let AI do something. But that way of thinking is gradually changing. This is the up-to-date number coming up from the Ministry of Internal Affairs and Communications. Individual, almost like a 30% people, Japanese people are using. Of course, that is the compared to the other countries, okay, still smaller number, but yeah, we are the aging society. Lots of the aged people, but still 30%. That means okay, quite large number of people are start using AI on the day-to-day, everyday life. Then question is moving from, oh, is Japan using AI to the next level? Okay, whose AI is Japan using? Then this will be the sovereignty question. I know European Union, data sovereignty or AI sovereignty really care about that. I have seen the data, like 70% of the European corporate data is under the American company or American servers. That's a big problem. That's why Gaia X or lots of initiatives are happening in Europe. Same thing happening in Japan. Especially we are the manufacturing nation, Japan. Every single company, we have tons of precious data, industry data. Okay, all of those precious data could be eaten by ChatGPT or Claude or American language models? That's the question. Then sovereignty. Okay, we should have Japanese AI to be used in the Japanese manufacturing floor. SoftBank, as you know, now their valuation is higher than the Toyota. Believe it or not. But the SoftBank lead the National Foundation Model effort. That is the lots of big Japanese companies come together, then create a big group of the companies, then creating AI dedicated for the Japanese manufacturing industry. We should create that. Then headquartered in Shibuya, of course, AI company, every AI company is located in Shibuya district in Tokyo. Then this group, SoftBank, NEC, one of the biggest electronics, Sony, then from automotive, Honda, then 3 mega banks and steel industry, those people come gather together. They are trying to build physical AI, 1 tera parameter, huge multimodal robot machine integration AI model by 2030. Then other than those founder group, 30 manufacturing companies are in discussion how to use, how can I join. And also government initiative, GENIAC, that is in METI and NEDO. Yeah, METI, NEDO, okay, you could read the, these government initiatives and fund. Then actually they put huge money on that. Then AI-ready manufacturing data and robot foundation models, we should make it for Japanese manufacturing purpose, not rely on other countries' frontier models. That's what they are trying to do. Then Japanese government, which AI are they using? Of course, in the government data, precious data, that is the national security issues also. Then coming up the project, digital agency launched GENNAI project. You could see the name, 7 different domestic developed large language models. Each of those are dedicated, specialized for the specific industry sectors. One of them are for finance, for example. One of them is government documents. One of them is manufacturing, so industry AI or different aspects they are looking at. Then all those 7 combined into one, into the box of GENNAI. Then that GENNAI AI box will be available for the government servants, 180 civil servants. They use those models for their daily life to maximize their efficiency. Then this GENNAI name is named after this guy on your right-hand side, Hiraga GENNAI. This is the guy from 300 years ago, Edo period. He was the famous inventor. And some people says, oh, he's the Japanese Da Vinci at the time. Actually, he brought the new technology into the society. He's a quite famous guy. That is why such a new technology coming into the society, named after GENNAI. This GENNAI software AI package will be purchased by the Japanese government. Then government civil servants, they will use this for their own purpose. Every chapter I prepared opening for partner page for the sake of the Austrian audience. Okay, Andy talking about a lot of things. What is the exact opportunities for us? Make it easier for you. Okay, these technology background, then these cores, these technologies, Japan already owns. You may not have very much space, but these areas, you have lots of room or you have some space for penetrating into the Japanese market, business opportunity for you to see very easily. I prepared such a page on every chapter. Then this is AI things. Sovereign foundation model around Japanese industrial manufacturing data, tons of data, millions of manufacturing companies all over Japan. Then how to get connect with the this Japanese sovereign foundation model. This is a key. Then I know Europe, you have a Gaia X, then automotive Katina X, or manufacturing X, or semiconductor X, or lots of blah blah X things. Then that Gaia X, we have similar things. Uranus data system. Then that Gaia from Europe and Uranus from Japan, they are connected together, interconnection, and the international connection link is available. That means you do something on the Gaia X or manufacturing X to support the small, medium size of the manufacturing companies, or those services might be quite relevant to the Japanese market because we are trying to do quite similar type of activities here. Data, security, safety, and also vertical applications put on the this foundation models, or how to put AI, how to run AI in the manufacturing stage, or that things. You have lots of room for to be the partner of those Japanese activities. Okay, go to next chapter, embodied AI and robotics. I would look back some years ago. In 2024, January, Las Vegas in the States, CES, Google built up huge pavilion. They talked about, hey, you guys, stop writing. AI will write for you. Human beings, you don't have to worry about bad writings or is it in the right spell or anything. No. LLMs became useful tools to support your language, your writing, because AI learned language, what we speak. Then 1 year after, our favorite leather jacket guy, Jensen Fan, NVIDIA, he mentioned buzzword, physical AI. That means our natural language can control machines. Hey, robot, pick up the toast and place it on the white plate. Years ago, we had to determine XYZ, type in the numbers precisely, and how many kilograms to grab the toast. But you don't have to do it anymore. Just let them know what you want to do. Then they understand your language. Then machine will start operate. That is the Jensen, show the future, physical AI. Then that buzzword coming all over the world. Then this year, 2026, robot circus. This is I was in Germany in April, Hannover Messe. Then one of the hall was lots of robots dancing, not singing, but jumping and hopping around and then backflip and whoa, that was the robot circus. Like a famous Unitary, or especially this China area was wow, lots of robot activities. Small kids will love it. That situation. Then my question, hey, okay, that's entertaining, looks fun, but are we really put these guys in our manufacturing flow? Are we really convinced for industrial deployment? Maybe not. I have to say one thing, humanoids don't need to walk. Look at these. For example, on the right-hand side, this guy is called Garbot from China. Actually, they found it 2 years ago, then already unicorn. Then this guy moves around the factory floor really fast and very easily grab a box, even if it is 20 kilo, then moving around. You don't have to walk. And also one European company, Hoshini, this robot, yes. You don't need a walk. Just one pair of hands. That's it. Then before we solve walking, we need to solve gripping issue. On the picture left-hand side, these robots grab box, put something in the box, such a demonstration. So slow, takes forever, do something. And such a big hand with 5 fingers, they are cheating because they don't use 5 fingers. Just a thumb and index finger, or maybe middle finger, that's it. But the index finger, middle finger moves all the time together. That means just the chopsticks, just the 2 sticks moving around, then pick up the things. 5 fingers doesn't work. Big issue of gripping something. This is where we are now on the robot. I call it finger paradox. More fingers robot has, that'll be better? No, I don't think so. More fingers, that means more moving parts. our fingers, every finger has 1, 2, 3, 3 joints, and also moving direction, that means 4 moving parts. Then times 5 fingers, that means our hand has 20 moving parts. Then physical AI, calculation, simulation in the virtual world for these 20 moving parts. That's too much calculation. What we really want to do is just grab an apple from the table. That's it. For such a single task, too much calculation happens if we use 5 fingers like we do. Then, top runner in the market, Boston Dynamics from Hyundai, Korea. He has just 3 fingers. Then perfectly works. He does lots of job. Then he will start working in the Hyundai automotive factory from this year. And also you can place an order then to be delivered within 2 years because the first year order was already sold out. Yeah. Then, okay, they are the 3 fingers, right? Then, but still Elon Musk, Tesla Optimus, he tried to create 5 fingers, but I don't know what's going on. But my suggestion or my message here is maximum humanity mimic or imitation is not the goal. We should let them work first and also we should avoid the explosion of the calculation. Not too much physical AI calculation just to achieve single task in the factory. That is why more fingers is not always better. Coming back to the Japanese topic, Honda recently launched one hand. That is the multi-fingered hand, but they intentionally dropped pinky. Just the 4 fingers hand and the 16 moving parts. Then they more focusing on the sensors on the fingertips. 288 channel tactile sensor. Then that finger can hold very, very small screws like you see the picture. And also this finger can hold the needle. Then you can put the thread into a small hole or such a tiny, tiny mechanical force you could add. And also, if you let them bring some heavy stuff, also they can handle that. That means precise control of the joints and the fingers and force, moving power, how to control, that technology is really necessary to ensure the better gripping. Then they put the new technology, which is called the wheel drive. That's of course in the motor direct response plus wire drive power. That means first grabbing force and keep the finger tight to hold the things, and then such a precise control can be achieved with that way. This is the finger things. And also in Japan, we have lots of companies like Harmonic Drive, Navtesco, Nidec. Those people are specialists for the moving parts, especially joints. Robot arms moving from left to right or up to down and moving very precisely, million times. But all the time very stable, such a high fidelity moving components available from Japanese those suppliers. That means, okay, Elon Musk, he's still dreaming about the 5 fingers. But the Honda dropped the pinky, 4 fingers, and Atlas 3 fingers. Okay, max human, not necessary. Let's see what's going on. Where Japan is open, robot market. As I told you, we have joints, very precise one, robotical moving parts, and hands. But still, we have lots of collaboration opportunity, open layers, sense, software. We need more sensors. That's true. And also software, safety logic, especially collaboration with robot, how to secure the safety distance, but we need to stand next to each other, or that situation. And the digital twin simulation software, we really need that technology in Japan, even though we have some good things in Japan. But then we have lots of room for that for you from Europe. Chapter 3, semiconductors. Yeah, actually, this part is quite crucial to talk about the geopolitical things. Let me talk about a little bit here. So semiconductor industry's big topic is helium, I understood. But this is the, of course, we need a cooling and so on. Then I know global level, big issue here. But then in Japan, locally, actually, even bigger problem is the naphtha. That is the even bigger problem because Japan imports naphtha from Middle East up to 60%, and also that import 70% from directly from the Gulf area, Middle East. That is why that war happened. Then okay, how many oil ships coming back to Japan? That was a very serious issue. Then Japan holds the very strong market share on the semiconductor chemical area, but those chemicals need naphtha. That is why this is considered as the more serious issue in Japan. Even though Taiwan, Korea, other Asian countries look really serious, the helium issues. Japanese semiconductor industry. We are not the top anymore, unfortunately, in the field of the frontier node, really cutting edge area, 2 nanometer things. Okay, TSMC, Samsung, Intel, those companies they are burning cash, huge amount of cash, then do the research and development, and wow, that's great. But on that area, we are not really competitive, and also we don't have very much player on that level. Rather, we are quite competitive on the packaging or interconnect, or also we put a lot of effort on the next generation like a silicon photonics, and we are riding on the wave of the lots of big demands of the memories and power semiconductors. Still, yeah, we are competitive in Japan, and some necessary materials in the process of the semiconductor manufacturing. We are focusing on those areas, but frontier node 2 nanometer, we just put one big bet on the Rapidus. That is the happening in the northern part of Japan, Hokkaido. Then 2 nanometer, yeah, gate all around semiconductor foundry. That is the last year. Okay, plan is ongoing, and also cutting edge manufacturing equipment from Netherlands ASML got to be delivered, or such a topic we talked about. But now this process is moving toward to the mass production 2027. Then this year, actually prototyping is starting. That is the current situation. Then Rapidus CEO talked about the over 60 potential customers in discussion. Most of them are quite cutting edge AI chips, ASICs. Then most of them are from overseas customers. So that means big one bet, Rapidus 2 nanometer, gate all around. This will be successful or not. I do really hope successful. Let's see what happens this year, next year. But original plan 2023, 4. Oh, really? Can you do that? Is it really? Could be on the track? Yes, on the track. It's moving quite well. I see that. talking about AI. Okay, physical AI and whatever, lots of AI topics. Need a calculation, GPU. Yes, we need the GPUs. Then new type of chips, NPU, or okay, GPU need a good CPU to control. Okay, those calculation power, computing power, that's true. But real problem now is not the computing power, how to maximize the computing power, how to support the computing power. That is the data bandwidth, and also fight against heat, thermal issue. That's the challenge for the moment. Then NVIDIA, they talk about photonics, change electron into light, right? Then they talk with the TSMC. TSMC launched the Coupe process. That is the silicon photonics, let's say electricity, and also photonics right, that conversion, that process. That is the already available on the TSMC. Then NVIDIA, QuantumX, Broadcom, everyone on that process. Then change into the diving into the silicon photonics stage to achieve high speed bandwidth, and also in power efficiency, lower temperature, less thermal issues. That is the future they are looking at. Japan, we may not have the core things like NVIDIA, Broadcom, or TSMC, Coupe, logic switch, ASIC on the core things, but we have a lot around that. For example, materials, substrate could be delivered from Sumitomo Electric or Kyocera. Laser optical components, yeah, Furukawa Electric is a big name. Actually, they have a quite long history on the optical fibers. And optical I/O, that's the I/O core. Yeah, I will talk about this company later. And the test equipment, Advantest. Yeah, such a big name. Then why that situation happens? Because we have a big platforms already exist quite a long time. One thing is NTT ION. NTT is the telecom company like Deutsche Telekom. Yeah, then ION is the next generation technology beyond 5G, 6G, such a technology development organization. Then ION already working on the this photonics, electronics convergence technologies. And Petra is the Japanese government-led development program. Actually, recently, last month, this Petra project dissolved, because then they already achieved enough amount of result of the development. Then they got dissolved. Then one of the result is this IO Core company. IO Core is came straight out from this Petra R&D project. Then they are the specialized company optical I/O components. Then those players are actually supporting the conversion from electronics era to photonics era, photonics electronics convergence technologies. So Japan will be ready for the silicon photonics technologies. Another topic from AI is a memory. Yeah, lots of GPUs, but we need a memory for the GPU to run the large language models. And also we need a storage, and oh, wow. These days, quite expensive to buy the things, yeah. That is because really high demand coming up into the market. Then one of the Japanese company got on that really fast moving and great wave, riding on that wave is the Kioxia. Kioxia is used to be part of the Toshiba. Then they are the NAND memory supplier, Kioxia. Yeah, their net profit YOY is 48 times bigger. Wow. That is still a big wave they got. Then, okay, AI memory boom is there. Then some of the Japanese company, yes, they earn lots of money. But not only the money, actually, they have a capacity 218 layer, 8th generation, 3D NAND. But this year, they came to the 332 layers. So they keep up the technology as well, not just earning the money. Power semiconductor. Also, this is one of the strong things in Japan. Yeah, big name like Denso, Rome, Toshiba, Mitsubishi. Yeah, they are competing with the European player like Infineon. Then power semiconductor market is booming and also expected to grow quite steeply because electric vehicle, of course, that's one of the attraction. Then the other thing is an AI server need a power supply. And also electric vehicle and charging station. Lots of power semiconductor will be required by the market. Then one of the big player and also one of the biggest Toyota supplier company, Denso, they try to acquire their competitor, Rome, for 1.3 trillion Japanese yen. But that action was withdrawn. Then now, Rome, they are in conversation with Toshiba and Mitsubishi Electric to merge together, create one JV for the power semiconductor unit. Lots of demand from the market and also market geography, how big Japanese companies are working together or compete each other, that geography is changing. That is the current situation in Japan. And also, I didn't write very detailed technical things, but of course, gallium nitride, how to create a vertical, or of course, that topic is ongoing. And also diamond or next generation development, yes, they are looking at quite actively. Nanoimprinting, NIL process. So standard semiconductor process is EUV optics process. That is the lithography. Then, yeah, $100 million equipment necessary to be purchased from the Netherlands. That is the really necessary things for the semiconductor industry. But how to change it? That's the this activity. Actually, Canon, Nikon, they were quite strong in the old days, EUV processes, but now they not anymore. Then they are look at the next generation technology. That is this NIL, nano imprinting process. Like you see, inkjet dispensing the resist, then stamp. Then create a circuitry. That is then basically the method how to create the semiconductor very fine circuitry. Then Canon create the tools. Then DNP, this is a Dai Nippon printing company. Of course, the printing company, they create a template. Then Fujifilm now is one of the biggest chemical company. Then they create a resist. And the Kioxia, memory company, they are the customer. Then all those are working together how to create the next generation process. Then this year, actually, since last year or year ago, TSMC or Samsung, big names of the semiconductor, repeatedly, actually, they showed strong interest on this NIL process. Then this process will be implemented into their mass production. That is the, we are talking about in Japan. Of course, that news we are looking at now, but let's see what happens. But this NIL process is quite ready for the mass production. This is the situation in Japan. So this is the last page of the semiconductor. Maybe we should talk about some future things. Quantum. Of course, quantum computing, yes, huge, giant cryostat. Yes, that's a quantum computing in the laboratory. Yes, In Japan, we do in Fujitsu or in different players. But quantum hardware, different types like a superconducting or ion trap, photonics, blah, blah. But the semiconductor silicon qubits type of quantum computing. This is the quite a good fit for the existing semiconductor industry because we could use the similar process of the creating the chips. Then this Japanese startup, BlueCat, they create small enough quantum computer which could be installed in the classroom. This black box, this is the same size as the 2 rack of the servers. Yeah, it's like conventional wardrobe size of the quantum computing. Yeah, literally you could fit into your bedroom size. Then this semiconductor quantum machine still in a small size, not powerful yet, but this will operate 0.3 Kelvin. This is low, quite high enough temperature. This is the quite breakthrough. Then they are looking at 1 million qubits by 2030. Let's see what happens. So next chapter, quantum sensing. I will talk about the sensing technology. Then one of the quantum sensing technology, typically talking about is an MV, diamond MV center. Quite high technology and cutting edge and difficult to explain, but one artificial diamond, then small particle at the center missing, then put the laser in it, then red fluorescence coming out. Then that things could be used for the sensing, like electric fields or temperatures or magnetic fields or that things. Then this technology originally just available in the laboratory, but now this laboratory technology coming into the industry level, available for purchase. And also this will be implemented into the automotive industry. Such a thing is happening in Japan now. In Japan, we have a Sumitomo Electric. They are the, very strong in high pressure synthetic diamond creation. And the Nissin Electric, they use that diamond built into the USB powered small MV module. Then that module could be used in the mobility automotive industry. Then why that things happened? Because we have a quite good technology ecosystem there. Initiative called QLEAP, Quantum Leap Flagship Program, that was led by the Japanese Science and Technology Agency. Then that works really good. And the Science Tokyo laboratories had a significant result. And of course, Hamamatsu or those photonics specialized company. Actually, Japanese companies are really working on those next generation of sensing technologies. Yeah, one of the example. Last month, there was an automotive engineering exposition in Japan, in Yokohama, very close to my office. Then Sumitomo Electric showed these things. This is a diamond NB quantum sensor module on the desk. Then they showed this small 12-cent small box module. This will be available for the automotive market. That means Japanese industry, diamond quantum sensing stack, from material, make it module, and actual application, moving to the commercialization. Sensing. Actually, we need the sensors, lots of sensors. This is the current situation. I talked to several people from automotive industry or AI or robot people. Everyone talking about need a sensor because AI will be on the car. AI will be on the robot. Then they try to interact with human beings. Then, of course, they should understand what state I am, what mood I'm in, my health condition, okay or not, am I sleepy or not, or AI, robot, car, they try to do something, serve something, help something to me, but they have no idea what's going on without sensor. That is why really need a sensor. Then this demand is quite high. Especially I talk to the different automotive industry people. Wow, do you know any good sensors? They are actively scouting those sensors. This will be a huge chance for you. So where you could collaborate with Japan. We bring the base of the sensor module and research or quantum grade materials and so on. Then we need a connection with the each industry. Then that could be based on this material. Then you can build a sensor, or you have similar technology, but you already result in the specific industry area, or actually, this area lots of opportunity to collaborate with. Last one, chapter 5, AI for Science, Smart Laboratory. As I told you, AI starts writing 2 years ago, 2023. No, 3 years ago. Then last year, robot understands what we talk about. Same thing happening in the laboratory. So AI will design molecules or materials, and also AI will run the experiment automatically. That means robotic, highly automated, autonomous laboratory starts up running, like autonomous driving or autonomous manufacturing by the humanoid robots. Looking around the world, lots of clever people already started this process on the different field, like AI designed drugs or processing materials, those things. Then autonomous, of course, closed loop, design, make, then trying the test, then okay, run the result, then design again, then automatically this closed loop running over and over, then development will be accelerated. Such an autonomous laboratory action is really ongoing. Japan, of course, we do a lot because Japanese strength is measurement equipment. You could see lots of Japanese brands in the laboratory, right? Shimazu, Horiba, JOL, Rigaku. All of those are working on autonomous laboratory systems. Then Japanese flagship is digital laboratory. This is the Hitotsugi laboratory from University Tokyo, Science Tokyo Interconnects. Yeah, look at this. All of those test equipment, robotic, and measurement equipment from Japanese company. Yes, they got autonomous. This is the things AI-driven laboratory start working. And also to support that, lots of government initiatives are starting. Actually, this is the ecosystem example. Like, AIST, they support of course, they have a program of the autonomous experiment, collaboration, robot things, automation. And also we have startups like Erix. They are the drug discovery company working with the Tohoku University. And Matrantis is one of the most famous guys. They are the AI material simulation people. Actually, they got the investment from Enios, one of the biggest petrol company in Japan. Such a, really ecosystem is around that on the autonomous laboratory theme. Then now, actually, convergence point is coming up here. Lab system is one system, but piling up different layers. That means instrument, components, analytical instruments. Okay, some of those, like analytical instruments, we are very strong. Automation, yes, Japan is very strong, but the software or any other layers, lots of missing area, missing parts. this will be the great opportunity for you from Europe. Japan owns the instruments, materials, AI engine, some of them, but still we need even better AI engine softwares and lab automation integration, robotics, measurement. Yeah, lots of room for the collaboration, those things. Yes, then now, 8 minutes remaining. Yes, wrap up. AI data, yes, we are working on Japanese AI sovereign things. Yeah, not too much rely on US, China frontier models. Robotics, we don't dance, but we have hands and joints, motors. Semiconductors, yeah, big hope for the Rapidus, for the frontier. But any other things, leading edge, next generation technologies like silicon photonics and the NIL process, yeah, we are really working on that. And the sensing technologies, yes, we need sensors to work with AI robots. And AI for science, like autonomous driving, like autonomous manufacturing by the humanoids. Yes, laboratory, day-to-day research things will be autonomous. This is the message.
And I would close the webinar today. Thank you all for attending. I once again want to hint, we have the Chassis 2026. This is all about sensoring measurements in all kinds of industries, whether you're delivering parts of it or whether you have the instruments themselves. Please participate. It's a very easy way to participate and get a good gauge on the Japanese market in your field. Andy will be there representing you also in the seminar. So you have a very great guy talking for you. So yes, please drop us a line. We're here to help you in the Japanese market.
Yeah.
Thank you so much for joining us today.